And welcome back to the channel. So today we will be discussing about the bisection method and how we can find the root of an equation using the bisection method. So let's understand its method together, and later on we will see that how can we implement this method using the Python code. So let's get right into it. So before beginning, let's understand what bisection method really is. So it is a method to find the solution of algebraic equation by taking the average of the initial point and the second point. So let's consider 2 points A and B, or you can say x0 or x1. These 2 points are the points that we have taken to find the value of the root. So in this method, the root is found by finding the interval between the first point and the second point by halving them using by taking their average. So let's consider we have 2 points, one is A and one is B, and we want to find an interval between these 2 points. So we are gonna suppose it as C and find the average of the point A and B. So the average of point A and B will be the interval between these 2 points, which is C. After that, the function of C will be calculated using the given function that we have. Let's say that it's fx. After calculating the value of fx, or you can say fc, we get the answer in the negative or positive value. Once we have calculated the value of fc, then we will check that whether or not its sign is equal, its sign is the same as fa and fb. Let's say the sign of fa is negative and the function that we found, that is fc, is also negative. Then we will replace the value of a with c and move on to the second iteration. To better understand this method, let's consider a live example. So we need to determine the root of the given equation, which is x square minus 3, using these 2 points 1 and 2. We have taken the values of x as 1 and 2. So let's get started. First of all, we are going to consider the f of x, or you can say y, as the equation that is given. Now we're going to put the values of 1 and 2 one by one to find the functions of 1 and 2. So as you can see, we found f1 and its value is negative, and we found f2 and its value is positive. This will make a difference in the coming steps of the question. Moving on to the first iteration, we need to find the value of x1, which will replace either 1 or 2. So to do that, we will simply take the average of 1 and 2 by adding them and dividing them by 2, and we get the answer 1.5. After that, as we discussed, we are going to put this value in the function of x. After putting the value in the function of x, we get the answer minus 0.75, which is a negative value. So based on this value, we are going to decide that whether we are going to replace 1.5 with 1 or 2. So as you can see, the sign of f1 is negative, and the sign of f of 1 and the sign of f of x1 is also negative. So we are going to replace 1.5 with 1. Now moving on to the second iteration. As you can see, to find the x2, we are taking the average of 1.5, which replaced the value of 1 and 2. After calculating the average, we get 1.75, and once again we will put this value in the in the function of x. After putting this value in the function of x, we get the value 0.062, which is a positive value. Now, as discussed before, based on this value, we are going to decide the value that we are going to replace with 1.75. Since the sign of the value of this function is positive, and also as we can see the sign of f2 is also positive, we are going to replace 2 by 1.5 in the next iteration. Now, in the third iteration, we are going to find x3 by taking the average of 1.5, which remained the same as before, and 1.75, which we replaced with the value of 2. The average is once again found, which is 1.625, and we have put it in the function of x and got a negative value. So these steps will continue on repeating once we have find the root. Now, how will we know that we have found out the root? For that, we will, for example, if in the fourth iteration we get the value of x4 same as the value of x3, which is 1.625, then we know for certain that we have found out the root. Now that we have understood bisection method in detail, let's move on to the coding part and see how we can apply this method using a Python code. So I hope you people understood this method clearly. Now let's see how we can implement it using a Python code. So first of all, we are going to define a method called the bisection method, which will take four parameters: the max iterations, which will be 100, the first initial values, which will be a and b, and the function. In this method, we are going to implement our bisection method. Here is the example function that we will be working with, in which we will put the values of a and b and find the sign of the function. As here we have defined a and b as the initial values. Now, one of the requirements of this method is that the value of a is that the function of a and b must have opposite signs. Now, getting back to the main bisection method, first of all, we are going to create a while loop, which will be calculating the midpoint of these two values, and after that we will check whether or not the function of c is equals to 0. If that is equals to 0, then it means we have reached the exact root, and we will return the value of c and the number of iterations performed. Another condition that we have set is if the function of c multiplied by function of a is less than 0, then we will set the value of b to the value of c. Now, basically, as you people remember, we replaced the values with the same signs, so that same thing is happening in this block here. After that, the iteration counter is incremented, and we have also set another if condition, that if function of c is equals to 0, then this will break out of the while loop, since we will have reached the exact root, so that no further iterations will be performed. Once we have broken out of the while loop, we will return this value and the number of iterations. And in the end, we have simply used the print statement to print the approximate root and the iterations performed in this method. So let's see how it goes. As you can see, our approximate root is 1.732, and the number of iterations performed has exceeded the limit that we had set. So this method varies value to value. It all depends on what values we have set, and what number of iterations, and what the threshold of the number of iterations is. So that's it for the Python implementation of this method. I hope you all understood it clearly. If you have any confusion, you can ask me in the comments below, and I'll be sure to answer it. Jazakallah. Allah Hafiz. See you next time.